Every time you visit a hospital, you're surrounded by life-saving equipment. Ever wonder who makes it? Here's a hint. We're called biomedical engineers. My name's Tom Smoot. I've spent 8 years in a medical research lab, and I'm currently a biomedical engineering grad student. I also started the Lift and Shift Foundation to help make science and tech more accessible. Let me tell you what a biomedical engineer does. Think you already know, though? There's a challenge at the end of this video. Now let's get to it. So where do you search on the internet? Google? Well, since AI is taking over, I asked ChatGPT how to explain biomedical engineering. Sometimes it makes stuff up, but I can set the record straight. Here's the key areas. All true. This covers basically everything I could be doing between work and school. Let me dig into this list a little further for you. Medical devices? Absolutely, yes. I think it's important to note, pacemakers and prosthetics are not the whole list. When's the last time you went to a doctor? Did the nurse get your pulse ox by clipping the little red light on your finger? Yeah? They probably put the little blood pressure cuff on your arm too, right? And heart disease is still the leading cause of death for nearly every demographic in the US. So if you haven't had an ECG yourself, you probably know someone who has. All these are devices where a biomedical engineer might be part of the design team. I say team because rarely does an engineer design any commercial device by themselves. It's almost always a team. Next up, tissue engineering. Whew, I lived this for a whole year. In my program, this was a year for both the lecture and the lab component. Tissue engineering is actually a pretty big field all by itself, though. In a quick summary, this goes way beyond cellular discoveries. It's more focused on scaling up to something called clinical significance once you discover whatever it is you're looking for. It's a lot harder than it sounds. Biomechanics, yep, did that too. I took a class called occupational biomechanics. We actually studied physical labor and covered things like repetitive use injuries. A lot of the examples in the class were based on a warehouse. It was stuff like person moving a box over and over and what happens to them. Just want to note this class was an elective offered from an industrial engineering curriculum. These last two, they're very much a part of biomedical engineering. I would know. I love this. I work with a radiology research lab, and our group uses MRIs to study cellular metabolism. I believe that checks both the boxes. Just like tissue engineering, these are massive fields. We could do bunches of videos on either of these topics, but I'm definitely not prepared for that right now. Okay, all this sounds cool, right? Now you're probably asking, how do I become a biomedical engineer myself? Let's talk school. Spoiler alert, we're engineers first, biology nerds second. I grabbed the undergrad curriculum from Johns Hopkins. I think they're ranked number 1 right now, but definitely in the top 10. They're always there. You can see here, just like all engineers, BME gets a solid background in what's called the hard sciences. That's a year of physics and chemistry. Math. Math is a big deal. This is 3 semesters of calculus that includes multivariable calculus, linear algebra, differential equations, but which, by the way, you'll probably never escape as an engineer. Sorry, but if you think you're bad at math, you're not. You're just not learning it the right way for your brain. Here's a quick math tip, though. Practice makes perfect. The biomedical core, it's actually a lot of systems courses based on biology. Don't get all wrapped up on the word systems, though. Think things like biomedical data science or cellular biology topics. Note the computer science too. This is common across engineering. You'll be expected to write code just like the rest of us, probably in Python. So prep for it. There you have it. This is a typical BME program. Johns Hopkins might be the gold standard, but most all other BME programs will look just like this. That's where I'd rather leave the boring campus chat, though. I'm not here to pitch anybody on a school or do any recruiting. Now for the challenge. Does this exoskeleton look like a biomedical engineering project? Survey says, wrong. It's actually led by the mechanical engineering department. This is a common misconception that your engineering discipline will limit the type of work you do after college. For example, my undergrad was actually electrical engineering. If you found this valuable at all, do me a favor. Drop a comment about what you want to see next and follow along. I'll be telling you more about these key areas we covered with ChatGPT.